This is Unit 1, Module 1, segment length and midpoints. So let's go ahead and get off with some definitions because in geometry, definitions are important. So our first definition, a point. It's a specific location, it has no dimensions, and it's represented by a dot. We don't care about the length, the radius, the diameter of the dot. It's just a dot. Okay, in this situation, we call it P. So in ways of naming it, we say point P. All right, next up, a line. A line is a connected straight path. It has no thickness and it continues forever in both directions. That's what these arrows mean. Okay, so the arrows just mean you have 2 points with a line cutting through it, and it just continues on forever after they pass through the points. Also, fun fact, you need 2 points to form a line. All right, now when we write it in an argument or in a proof, we would often say line AB, and we would write it this way. Or, depending on where you're standing from your points, line BA. Same. Okay, just you're thinking more about maybe person B as opposed to point A. Okay, I like to think of points as people sometimes. Okay, next up, a plane is a flat surface. It has no thickness and extends forever in all directions. So as you can see here, X, Y, and Z, they all exist and they are coplanar on plane R, fancy R, okay? All right, so that was a plane. All right, definitions continued. So line segment or segment is a portion of line consisting of 2 points. Both points are called endpoints. For example, our endpoints here are C and D, okay? Now, when we write this in notations for proofs, we would say segment CD, and we would write it that way, or segment DC, and we would write it that way. Next thing up is a ray, and it's a portion of a line that starts at a point known as the endpoint and continues forever in one direction. Now, you still need 2 points. So here's your endpoint, endpoint P, and it's shining a light or a beam of light in a certain direction, and it's in the direction of Q. Okay, Q is like a directional point, all right? The light still goes through Q and continues on forever, okay? So that is a ray. When we say it, we say ray PQ, but when we write it in notations, it'll be PQ with a little ray up on top. And that's how we would write it in our proofs. Your turn. Number 1, draw 2 points, J and K. Make sure you label them. Then draw a line through them. Remember that a line shows arrows at both ends, so don't forget the arrows. Your turn. Number 2, draw 2 points, J and K. Again, this time draw the line segment with endpoints J and K. So again, this is just a line segment. All right, your turn. Number 3. Draw a point K again and draw a ray from endpoint K. So plot a point J along the ray. So K is your endpoint and it's going a certain direction, and that's where J comes in. Okay, just like the example that I gave you. All right, let's see, your turn. Number 4. Draw 3 points, J, K, and M, so that they are not all on the same line. Then draw a plane that consists of all 3 points. So look at your definition of a plane and go ahead and see if you can do that, if you can draw it. Make sure you label it. I think here they said you can label it like crazy B. If you want to use the R again, you could use that. That's really up to you. It's optional. Okay, so make sure you draw it in your notebook as well with the whiteboards. Okay, definitions continued. So I did mention this word earlier. coplanar. Okay, basically, you have points on the same plane. They coexist on the same plane. So coexist, planar, plane. Okay, lines that lie on the same plane that do not intersect are parallel. So if I was to draw that for you real quick, it would look like something like this. You have your plane. Okay, we'll call it fancy R. Okay, plane R, and we have this line here that happens to be parallel because it will never cross this line. Okay, they'll never intersect. So that's an example of being parallel. Okay, now points that lie on the same line are collinear. A good example of this would be here. So collinear, if you notice A, B, and C, they all exist on the same line. They are collinear. Okay. Now, the segment addition postulate is the first postulate that we actually teach you this year. So, a postulate, what is that? Okay, so if you look at the definition, a postulate is a statement that is accepted true without proof. That means you don't really have to prove it. Everybody just accepts it as the truth because, well, it's obvious. So, for example, A plus BC, so these are segments. So you have A plus AB plus BC equals CD. Oops, sorry. There we go. Let me get back the green. So that's basically what I'm saying there. Okay, I like using the colors because, the colors kind of say what I'm talking about. So notice how AB plus BC creates AC, the whole thing. This part plus this part creates the whole thing. Okay, so think of that logic. All right, the distance formula. So let's say, for example, you have a Cartesian plane, and they went ahead and gave you coordinates. So let's say that our first point here, our ordered pair is, let's say, 2, comma, 3. And your ordered pair here is 8, comma, let me try to get creative here. Yeah, sure, why not? Yeah, I could do that. 10. Okay, so this is an example. Well, just like the formula says, basically you have your second x minus your first x. My second x was from my second point to the right, which is 8. So I have 8 minus my first x, which happens to be 2, and we square it, plus our second y, which is 10, minus our first y, which is 3. And don't forget, we square that. Now, let's go ahead and go down a little further in the rabbit hole. 8 minus 2, that's 6. Don't forget we're squaring it. Plus, we have 10 minus 7, or 10 minus 3, which is 7. Sorry, my brain went a little too fast. And 6 squared is 36. 7 squared is 49. So our distance here, we can actually move a little further here. That's a 1, that's 8, square root of 85. Okay, so our distance equals the square root of 85. You would have to make that a rational number. If you type this in your calculator, you should get an approximate. It'll be like 9 point something something. Okay, if it was in feet and we were asked to find the distance or the length of this segment, it'd be in feet, and you would probably say feet. So if they do something like that to you, be aware of units. Okay, now your turn. Number 5. What other method could you use if you were on a Cartesian plane other than the distance formula to find the distance of two given points? Hint: what theorem helps you find the hypotenuse of a right triangle? So, remember this is a right triangle. Could you find the difference between this to find the length here? Could you find the length from here? And then what could you use to find the hypotenuse? It's a theorem, and I know you learned it. So ask your group, talk about it, see if there's another method. All right, your turn number 6. Determine whether the given segments have the same length. Justify your answer. So I'm going to work with AB and CD. I want to see if their distance is the same. So again, AB, the segment AB, will have the same distance as segment CD. Let's find out. Well, based off your turn, you should have realized, oh, Pythagorean theorem. And Pythagorean theorem does something quite special. And sorry, my drawing, for some odd reason, I like to blame the tech, but it was definitely my hand. I kind of like put it at a weird angle. All right, so notice the Cartesian plane. We have tiles. I count 2 tiles down, and 1, 2, 3, 4, 5. 5 tiles across to point B. If you look at CD, from D, we can go down 2, or to the left 2, and go up 5. 1, 2, 3, 4, 5. So if you realize Pythagorean theorem, you'd realize, well, if I use Pythagorean theorem for AB and CD, I want to have 2 squared plus 5 squared for its hypotenuse, and 2 squared plus 5 squared for CD's hypotenuse. That's going to equal the same. So these guys, AB, segment AB, and segment CD, have the same distance. Okay? So notice how I didn't use the distance formula. I could have. And I'll tell you what, go ahead and do it. Go ahead and use the distance formula. Okay? Go ahead and use the distance formula. Double check my work. See if it makes sense. And just double check. If their distances are the same, guess what? Pythagorean theorem. You just proved it. Okay, you proved that you could use either or on a Cartesian plane. Now your next question: what about E, F, and GH? Do they have the same distance? You could try Pythagorean if you want. Just please justify your answer. Either you're using the distance formula or Pythagorean. So make sure you pay attention to that. All right, finding the midpoint. Now a midpoint is another piece of information that you have to know. It's just one of those words. Midpoint. If you look at point M here, it is a midpoint of PQ because the distance from PQ, or I'm sorry, from MP or PM is the same length or distance from MQ. That's what I note right here with these little slash marks, okay? This distance is the same as this distance. So it's in the middle, okay? Now a segment bisector in our industry refers to this line cutting across right through the middle of our line segment. That is what we call a segment bisector. Bi means 2. It's because this segment is being cut in half. It's being cut in 2 by a bisector. Okay? All right. Now the midpoint formula. It's basically finding the average, and you're finding the basically the point in the middle. So let me explain. Let's say point A was given to us by 1, 1. All right. And point B was given to us as, and this is the example, as 9, 9. All right. If I was to apply the midpoint formula, I just add up the x values, divide by 2. And then for the y value for my ordered pair, just add up the two y values, divide by 2. So if we do that, let's check our x values. Our x value here was 1. Our x value over here was 9. So we have 1 plus 9, divide by 2. Let's check our y values. 1 plus 9, divide by 2. And our midpoint will be 10 divided by 2. I'm just showing you all the work. That way you can see the process. Sometimes it's all about the process. And eventually, at the very end, your answer, your midpoint, will be at 5, comma 5. So that's an example of how you apply the midpoint formula. Usually it's a Cartesian plane. Sometimes I will give you a verbal question with the coordinates, okay, like I did here. Sometimes they do that in word problems, so just be aware of that. All right, your turn number 7. So instead of just using the midpoint formula, I want you to show that this statement is true by the midpoint formula. So they give you a line segment. They say the endpoints are here and here, and then the midpoint M of AB is at the origin. So remember, the origin is at 0, 0. So apply the formula that I just showed you and see if this is true. Okay, talk to your group, see if it works. Thank you guys. Have a great day.